Hey everyone, in this lesson we're going to be talking about how to find the area of compound 2D shapes. So the keyword here is compound. So compound shapes are the ones that are made up of two or more shapes that you're actually more familiar with. So typically in mathematics, when you guys have more than one basic shape that you're familiar with, then you basically can put those together and come up with a compound shape. So just a little quick reminder about what we already talked about in the past. This is the formula for area of a square, formula for area of a circle, area of a rectangle, which is base times height. An ellipse is pi AB. A parallelogram is base times height. Any triangle is 1/2 base times height. A rhombus is 1/2 p times q, where p and q are the lengths from corner to corner. The trapezoid is kind of like the same as the triangles, 1/2 base times height, but the difference is that these are actually two bases. There's a base on top and on the bottom in this case of the two lines that are parallel to each other. So it's 1/2 bases times the height. And then the equilateral triangle is area is equal to the square root of 3/4 times b squared. Okay, now that we remember the formulas that we're going to be using, to find area of compound shapes, we basically have something that looks like this, in which you're going to have to chop it up or divide it into other shapes that you are actually familiar with. So there's no right or wrong way of doing this. As long as you guys divide it into shapes that you actually know, then you can do it correctly. So there's more than one way as long as you get the correct answer in the end. So to find the area of this compound figure, so in my personal opinion, I think that the best way to divide this or chop it up is to make a straight line here, assume that it's straight, and have this be one area and have this be a separate area here. So we have area 1 and area 2. Now, what do we need to find the area of that circle up there? Or actually, I should say a half circle. So area 1, actually, I think I'm getting ahead of myself. So how many divisions did I have? So here I divided it into two different areas. What shapes do I have? So I have half of a circle or a semicircle. So semi is another way of saying half. So I have a semicircle or a half circle, and I also have a rectangle. So these are my two shapes. The area formulas are as follows. So for the semicircle, it's basically the area of a circle, but we're going to be dividing that by 2. So the area of a circle is pi r squared, but then it's not a full circle, it's a half circle, so we're basically going to be dividing that by 2. So that's one of the areas that we're going to be using. Another formula that we're going to be using is for a rectangle. So the area of a rectangle, which is area 2, by the way. So the other one was area 1. Let's call this area 2. The area formula for that's pretty easy peasy. It's just base times height. Okay. Once you know the base and the height for the rectangle, and once you know the radius of that specific circle that we're talking about, then you can actually figure out the area of the whole entire compound shape. And the way that we do that is basically by adding up area 1 plus area 2 to get the area total. So let's worry about the area 2, which is actually the one that's a little simpler, right? So area 2 is basically this area here. So the area of this rectangle. If you want to find the area of this rectangle, it's going to be base multiplied by the height. In this case, the base is 16 centimeters and the height is 7 centimeters. So let's substitute that in. So in this case, area 2, which is the area of the rectangle, is 16 centimeters multiplied by 7 centimeters. So 16 times 7 is what I need to plug into my calculator. And when I do that, 16 times 7, I get 112. So then area 2 is equal to 112 centimeters. Don't forget that these are centimeters squared. Okay, now I'm going to go back and worry about area 1. One thing that I need to figure out what my radius is, but I don't know that. I need to figure out first what my distance from here to there is. And I can actually figure that out, right? So I know that from here to there is 6 centimeters. And I know that the whole entire thing on the bottom is 16 centimeters, right? So if I have this little bit from there to there, that's 16 centimeters, and the whole entire thing is 16 centimeters, then I know for sure that that little bit is going to be 10 centimeters. So therefore, the diameter of the circle is 10 centimeters because the whole thing has to add up to 16 on the bottom. Hopefully that makes sense. Now that I know what the diameter is, I can find the radius of that circle, right? So if the diameter of the circle is 10 centimeters, then the radius of the circle, so right here, R, is equal to 5 centimeters for that circle. So that's exactly what I'm going to plug into my formula. So the area 1 is pi times r squared, which in this case will be 5 squared, and then I take that and divide it by 2. 5 squared is 25, right? And then I take that and divide it by 2 and multiply it by 3.14. So I'm going to just plug in the numbers. Pi is 3.14. 5 squared is 25. And then on the bottom, I'm going to be dividing all that by 2. So let me get my handy dandy calculator. 3.14 times 25 divided by 2, I get 39.25. So area 1 equals 39.25 centimeters squared. Don't forget the units. Okay, now that we know what area 1 and area 2 are, how do we find the area of the compound figure? So what do we do with area 1 and area 2? So essentially what we want to do is add it up, right? So the total area is equal to the first area that we chopped up plus the second area. So the total area is equal to 112 plus 39.25 centimeters squared. And when I add that, I get 151.25. So my final answer, my total area, my area of my compound figure is 151.25 centimeters squared. So this will be my final answer here for my area total. Okay, hopefully that's simple enough. So again, finding area of compound figures, we basically are going to be chopping it up or dividing it in several other figures that we actually do know. Okay, let's try this one on for size. So what figure or figures do you see here? In my personal opinion, I think that if I were to divide this one more time in this form, I can see two figures. I can see a triangle that is up there, and I can see a rectangle that is on the bottom. So I'm going to do two divisions, and the shapes that I have are a triangle, that is the top portion, and then a rectangle, that is the bottom portion. The area formulas for triangle and rectangle are as following. For a triangle is equal to base times height divided by 2, or 1/2 base times height, same thing. So this is the formula that I'm going to need to use to find the area of the top triangle. And then the area formula that I'm going to need to use to find the area of the bottom, which is the rectangle, is just base times height. So there we go. We have everything that we need. Now we just have to figure out, okay, what are the dimensions? What are the lengths of the base and the height for each one of these portions? So let's go with finding area 1 first. So area 1 will be the triangle, right? So what is the base of this triangle? If you notice, the base of the triangle is the same thing as the base of the rectangle at the bottom, right? So this is the same length from there to there as it is from here to there. So I can say that this is also 8 centimeters from there to there. And the height is given to us as 3 centimeters. So then base times height will be 8 centimeters times 3 centimeters. And then once I get that, I divide it by 2. You can do it in the beginning, or you can do it at the end. This will be 24 centimeters squared. And then I have to divide that by 2. So when I divide 24 divided by 2, I get 12. So my final answer is 12 centimeters squared. This is the area of the rectangle, or the triangle, excuse me. Area 2 is the area of the rectangle, which is just base times height. So in this case, we have the same base, which is 8, multiplied by the height, which happens to be 5 centimeters, right? That's the distance all the way from the top to the bottom of that rectangle. And then 5 times 8 we get equals 40 centimeters squared. Don't forget the units. Is that my final answer though? No, it is not my final answer, because remember, I want to find the total area. The total area is area 1 plus area 2. So my final answer would be, I'm going to write it on the side somewhere, area total is equal to area 1 plus area 2, which is equal to 12 plus well, let me be specific, 12 centimeters squared plus 40 centimeters squared, and the final answer will be 52 centimeters squared. So my total area is 52 centimeters squared for that house-looking shape. Okay. Again, we're just doing divisions. Okay, a couple more. This one should be pretty straightforward after the last one we just did. There's many different ways in which you can cut this, many different shapes. You can make a bunch of rectangles, you can make a bunch of squares, etc. It's really up to you. As long as you figure out what the base and the height will be, in the end, you will get the correct answer. So I'm going to go ahead and just make a division. I'm going to go ahead and make a cut right here. And then I'm going to divide this as area 1 and as area 2. So I'm going to go with 2 divisions, and the shapes are 2 rectangles. So I'm just going to go ahead and get rid of that 2. Rectangles. They are both rectangles, so it should be pretty self-explanatory. The area formula for a rectangle is just base multiplied by the height. So that one's pretty easy peasy. The only thing we need to figure out is what is the base and the height for each one of these figures. So let's do A1 first. So the base and the height, right? So the base is pretty simple to understand. It is just 2 centimeters. That is the same thing on the top and on the bottom. So the base is 2 centimeters. The question is, what is the height? The height is the distance from all the way to the top of that rectangle to all the way to the bottom of that rectangle. As you can see, we have to add a couple of values here. So we have to add the 8 centimeters that was from here to there, right? That's that portion from there to there. But we also have to add this section from here to there to get the complete height. So we have to add 7 and we have to add the 8 to get the total height here on the left-hand side. 7 plus 8 will give me a total of 15. So then the height for this is 15 centimeters. Now that I have my base and my height, then I can plug it into my formula. So B times H. So then A1 is equal to 2 centimeters multiplied by 15 centimeters for A1. And that's going to be 30 centimeters squared. So there you go. I have one of my areas. Now I just have to find the other one. Area 2 is equal to the base and the height also. This one's a little easier to understand because the base and the height are already there ready to go for you, right, for this triangle. So as you can see, the base is 4 centimeters. Same thing as the bottom as it is the top, right? And the height is 8 centimeters. That's on the right-hand side. So B multiplied by H, that's equal to 4 centimeters multiplied by 8 centimeters. And the final answer will be 32 centimeters squared. Now, is that my final answer? No, I want to find the total area, right? So area total, the area total is the area of the compound shape. In this case would be A1 plus A2, or the first area plus the second area, which is 30 centimeters squared plus 32 centimeters squared, which gives me a total of 62 centimeters squared as my final answer for this compound shape. Okay. One more for comfort. So example number 4 is the last one that I have for you guys. Find the area of the compound figure, include units. This one is a little more challenging because you can cut it up many different ways. It really depends on how you want to divide this. I'm going to go ahead and you can make 3, 4, 5, 6, however you want. I'm going to go ahead and make 2 divisions only because I recognize this top shape. I mean, if you don't remember what it is, we actually already have a formula for that top shape. That top shape is called a trapezoid. So a trapezoid, by definition, basically has 2 lines across from each other that are parallel, and this actually has 2 lines across from each other that are parallel, right? So this line is parallel with this line. I mean, considering that I draw a straight line, which I can't if my life depends on it. But anyways, so that is one of the bases for the trapezoid. And then another base for the trapezoid would be here, which again is the same thing as the bottom. So we're going to say that that's 8 centimeters. So we could actually use this to be able to find the area of the total compound figure. So I'm going to go ahead and do 2 divisions. What are the shapes that I see? I see a trapezoid on top. I'm going to call this area 1. And I also see a rectangle on the bottom. I'm going to call this area 2. And then the formula for area of a trapezoid, the area 1 would be 1/2 base times height, kind of like a triangle, but there are two bases, base 1 plus base 2 times the height. So that's a formula for a trapezoid. They may have different letters up there, but it's the exact same thing, I promise. Area 2 is just a rectangle, which is just a formula base times height. So there you go. These are the formulas that I need to use. I just have to figure out what to plug in and what to substitute for the values of the bases and the heights, and then we should be good to go. So let's start with the trapezoid. For area 1 for the trapezoid is 1/2 multiplied by base 1, which in this case is the 8, plus base 2, which in this case is the 2. So it's going to be 8 plus 2, 8 centimeters plus 2 centimeters, times the height. This is the part where we have to actually do a little bit of analysis here. So the height, the whole entire thing from here to there is 7, right? So from the top to the bottom, that's 7 centimeters. And then from here to there, it's 4. Now the question is, how much more do I need to get the distance from here to there? And if you do a little bit of mental math, you could see that what's missing here is we're missing a total of 3 centimeters to get a total of 7 centimeters on the left-hand side, right? So we kind of already know what the height is for this trapezoid. The height for the trapezoid is equal to 3 centimeters, but it took a little bit of figuring out to do so. So we're going to plug in 3 centimeters there as our height, so we can correlate it with this formula that we have here on the right-hand side. Okay, so A1 is equal to 1/2 the sum of the bases times the height. So when we simplify this, we get 1/2, a plus 2 is 10, then we multiply that by 3. That's going to give me 1/2 of 30, and then 1/2 of 30 is equal to 15. So this is going to give me 15, and we're talking about centimeters. Don't forget your units, so centimeters squared. Now, that was the hard part. Let's do the easy part, which is basically just finding the area of the rectangle. The area of the rectangle is base times height. The base on the bottom is 8 centimeters, and the height is 4 centimeters. So it's basically 8 times 4. So 8 centimeters multiplied by 4 centimeters. 8 times 4 is 32, so it's 32 centimeters squared. Boom. So now we have to write the final answer, because remember, this is not the final answer. This is basically each individual section. So what we want is actually the area of total, the area of the whole entire thing. Area total is A1 plus A2, right? There's 2 sections, 2 divisions, which means that we're going to be adding the 15 centimeters squared and the 32 centimeters squared. So when we add those two together, we get a total of, or I should say an area total of 47 centimeters squared. Okay, so I hope this lesson was useful. If you guys have any additional questions, let me know in class. Have a great one. See you on the next one.